In this video, we will see how to perform hashing using Python, especially using the SHA-256 and SHA-512 to hash a particular message and get the hash string. So, hashing and encryption are two different things. Let's see the difference between the hashing and encryption so that we can understand what hashing really is. So, let's consider we have a message. So, with the help of some key, we perform the encryption to get the noisy data. It can be any encrypted data. So in the case of the encryption, we can actually using the same key, we can get the original message. Using this noisy data, we can actually get the original message. That is using the same key, or in the case of asymmetric, you will use the different key. But in the case of symmetric key, you will use the same key to decrypt the message back to the original message. This is how the encryption and decryption works, where you will encrypt a message using the key and you will also decrypt a message using the same key. As in this asymmetric, you will use this different key for encryption and decryption. But in the case of hashing, here where you will get here hexadecimal characters. It can be any string. It depends on the algorithm we use. In the case of SHA-256, we will get the 256 bytes, or in the case of SHA-512, we will get the 512 strings. One of the core features of hashing is that you can't get the original message using the hash strings. We can't get the original message because we don't have the enough information to get the original message. But in the case of encryption and decryption, it is a to and fro method where you will encrypt and you will also decrypt. But in the case of hashing, you can't do that. This is the benefits of using the hashing. So let us see how to implement this concept using the Python. For this, we will have something called the Hashlib module. So let's import this Hashlib. This is a built-in model, so you don't have to install any module. So let's import our Hashlib. This is the model that we are going to use in this video. If you want to see what are the algorithms are available in Hashlib, you can do that as well. So in this case, hashlib.available. So this is algorithms available. It will display what are the algorithms are available. You can see we have this many types of algorithms, but most of these algorithms will not work on most of the devices. If you want to see the guaranteed algorithm that work most of the devices, you can use the algorithms guaranteed. So algorithms guarantee. We can safely say that these algorithms will work mostly on all of the devices. So let me comment this out. Let us see how to hash a string. For this, we will first have to define the what algorithm we are going to use. In this case, we will be using the SHA-256. For this, h equal to hashlib.sha256, or you can also create this using the hashlib.new. In this new, you can specify SHA-256. You can define the algorithm in both the ways. So I will stick to this. After that, if you want to hash a string, just pass this string to the hash.update method. Inside this, just pass the string that you want to hash. In this case, hello world. The string must be converted to a byte form. So before the string, just pass B. B stands for byte. So this string will be converted into one byte form. Now if you want to get the hash value, you will simply call the hex digest method. So let's print that method now. So this is not the hash. As you can see, we get the hash value for the string. One of the core features of hashing is that even if you change a string slightly, for example, instead of small w, if you use the capital W, just look at that. This string will change drastically. For example, here now the string starts with 64. So let's look at the string now. As you can see, it completely changes. It now starts with A5. This is the power of using the hashing. One of the core areas where hashing uses is the case of password. For example, so let me comment this out. Let me clear this. For example, I have a password here. It can be anything. My password 123. So let's hash the password now. This is how you save the password in the database. You won't save the password just plainly. You will save the password in the form of hashing. If the user wants to verify that password, for example, this is the user password. So let's say this is the original password stored in the database. And the user types something like my password. He also types the original password. Again, define the SHA-256 now. Let's again hash the user password. Let's again get the user hash now. Since both the password are same, we will get the same hashing. But if the user types slightly a different password, like for example, instead of 3, he types 2 again. So let's save this and run now. As you can see, both these strings are changed very drastically. The first string start with 4 and the second string start with A. This is the power of using the hashing. This is really helpful in the case of storing the passwords. You can also hash a text file as well. So if, for example, if I want to hash this requirement.txt file, you will have to first define the buffer. This buffer contains, in this case, this will be 65,536. This is a random buffer number. Let's also open the file now with open. I'm going to open the requirements.txt file as f. While true, we will perform the read operation. Data equal to f dot read. We will pass the buffer now. If not data, if the data is reached the end of string, we will break the while loop. Let's encrypt the data now. Hash. Just pass the data to the update method. And after the while loop ends, let's return the h.xdigest. Instead of returning, just print the result now. So the as I told you earlier, the file must be in the form of byte form. So we will pass the second argument as read as a byte. As you can see, we get the hash for this file, requirement.txt file. Even if we change it slightly, instead of 2.2.0, we will change the Flask version to 2.2.1. So let's save this file and rerun our hashing algorithm. You can see the difference, right? Earlier it was something else, but now it changes drastically. So this is for this video, and I will meet you in the next one.